Hey everyone, welcome back. So today we're going to pick up where we left off last time, and that is going to be continuing our global Bikeshare data visualization in TouchDesigner. So I'm right here where, again, we left off after the last tutorial. We have so far completed this sandbox notebook that allows us to grab data from a URL-based API using Python, view that data, get real-time city bike station status information, like how many bikes there are, and then we can compare time slices against each other to identify where bike starts or stops occurred. So what we need to do now is create the rest of our main program, which is going to be the actual Python script that gets run as a separate process on our machine that will initialize our data, save our station locations, and then every 5 seconds call in our API to get the updated station status and record any changes that may have occurred. Those changes will then be sent via OSC to TouchDesigner where we can do the visualization. So what we need to do now is finish writing this main program. So we will start with defining a delay, and this is going to be 5. That is because that is the fastest refresh time of the API. So our API data doesn't refresh any faster than 5 seconds, so it's pointless for us to do updates any faster than that. So we can call this the initialization section. We will define our station data as just using that get station data function. Then we will borrow some of this line, for example. So here we will set up real-time comparison. Station data. I will print out a message. Successfully initialized. And then now we're going to use something from the time module. So we'll add that import time. And we will just have a little loop start time will be equal to time, and then iteration will be equal to 0. And then this will be a while loop, and we'll say while true, which means we will run forever. Infinite loop, while true, we want to do the following. That is have our updated data and our changes. Update from this get bike station changes function will pass in our original station data, and then we will pass in the old data as well. Then after the update, we will set our old data equal to updated data. Override old data for next time step. So now every time this loop runs, which will be, as we'll see, every 5 seconds, we will call this, we'll update the old data with whatever the most recent update was, and then that will be used as the input old data for the next call. Now, for any change in changes, we'll want to, one, know how many there are, and then two, do something with it. So we can say for change in changes, we can just print in changes.values, we can print that change, and then we can have another print statement that will print how many changes there were in total. So we'll do that with a string. We'll format the string, so putting an F at the beginning, running, and then we can use these brackets to dynamically replace, I guess, variables in our string. So we can do this, iteration elapsed, change count, and then here we have another variable, and this can be changes.shape, and we'll grab the first element. And then we can just close that string. We can add 1 to our iteration. And then we can use the sleep function to pause our program for this period of time before it iterates again on the while loop. And what this section is doing is simply counting the actual time difference to our start time. So actual time minus start time equals time elapsed since start, and then just doing that modulo the delay value so that we don't delay any more than that stated delay seconds. Then our loop will happen again, and all of this will update one more time. So we can run this program by going over to our console and running Python and then the path to the program. So that would actually be, in this case, python/main.py. And we'll see if there are any errors. There's one because I used a variable that didn't exist. But if I update that, again, also did not need that length. We can just grab the shape directly. Okay, instead of an equal sign, that should be a minus sign. Okay, and now we can see our program is running. It was successfully initialized, and it is now printing out every change. In this case, 31 for the last 5 seconds, and it's printing out what each of those changes are. Now, this isn't super helpful, obviously. Printing in tech support doesn't do a ton for us, but we can now validate that this change calculation is indeed working. And so now we can do the next step, which is going to be using OSC to actually get this information into TouchDesigner. So before we do that, I will real quick set up my export. so that we can just re-export every time we initialize this program in case stations come offline or go online. So to do that, we can just do station data export equals station data, and we'll do just the X and Y columns like that. And then we can do station data export dot to CSV, and we can just point it at this same path. Station locks file path, we'll make it a variable. And then you can just do this. So if you go back to this tech support or command terminal, Control C will interrupt the program, and then you can just rerun that again. We can see that our program is not quite running right, and that's because we changed the location. Right now we're running from main.py. So yeah, actually, I think that should work. Doesn't quite work. Okay, and there, I just had to remove the double dots. Okay, so now our export's working. So now what we need is a little bit of OSC help. So for OSC, we can go back to our code GPT and just say, I want to send OSC message over Python, an OSC message containing X, Y coordinates over Python for each event generated by my program. And we'll see that it writes us a pretty good function. So we do need this new module, which is Python OSC. So I already have this installed, but you will need to install it. If you don't, you can do that by using pip. So you can go to the documentation here and just copy this pip install python-osc, put that in the command line, and then it will install to whatever your active environment is. So I'll add that to my function here. From Python OSC, import UDP client. So now I will create a UDP client during my initialization. OSC port will be, I'll make mine 8888, and then OSC address, in my case, I will use 127.0.0.1. This will be localhost, and this is whatever port you want. Then I can set up my UDP client with my OSC address and then my OSC port. Then I just need to use this client.send message inside of my for loop and just send this message for every row. And so I can actually just pass this change row directly in as the message argument. And so let's see. I will interrupt. I will restart my program. It's running, which is good. It means our import's working well and everything else seems to be working. At this point, we can get rid of a lot of that and start looking at both of this at the same time. So first, we can simply drop an OSC in, and I'll point this at my same port. Eight, 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 eight. We can try, since we're not seeing it here, we can try to interrupt and just send a blank blank OSC message. That does also not seem to be working. So what I'll do here is actually go back to my sandbox, since again it's a bit more responsive. I will add something down here to insert my code directly. And I'll just hard code these values for now. And all we're looking to do here is see if indeed the OSC message is working, although I can't have this while true, so it should just be like this. Something does not seem to be working. Let's try a different port just in case that port is already being used. Aha, that's what was happening. So I am already using port quad 8 on another machine. So I will make this instead 99999. And I will rerun my program and we'll see what happens. I'll reset this OSC. And now we can see that we are generating an event, but we forgot to put change row back in here. So I will again restart my program and see what happens. Okay, so now we are getting events, which is good, but it's not everything that we want. It seems like we're just getting one event worth of data, and that is not exactly what we need. So one way that we can get around this is by adding unique channel names to each of the event channels. So for that, I will import another native Python library, UUID, and we will use this in our message to simply have a UUID, which you can get with uuid.uuid4, and we'll just have a unique identifier appended to each message. So now, if I restart my program and restart my OSC here, we can see that we are now getting a total of 174 channels for our 58 changes. Where's that at? 58 changes. So 58 times 3 is 174. We have 174 channels in our OSC in, so we're sending one channel for each of our coordinates in our message. It's worth noting that I guess we're including the gain loss in this message, so we're sending in for every event XY gain loss. And if I reset these, and then I will just run my program again. You can see that this is running an aggregating total for each hit. So this is just going to be an ever increasing OSC chop in because we're not clearing our channels. That is fine for the most part. You can handle a pretty massive number of channels without having too much overhead. So I'm actually just going to leave that as an ever running chain of OSC channels, since each of our events has a different UUID. And we're just going to work with that from here on out. So I think what I'll do is, so that we can see this working, I'll pause my program on this side. And I will open an Anaconda prompt terminal. So you can do that with from the start menu. If you just run Anaconda prompt, you'll get this command line interface. So then I just need to cd, which means change directory, to whatever directory your current folder is in. And then cd again to Python. So I think, yes, so we can see that I have, by typing dir, I can see what I have in this directory, and that is our main.py. So I will simply type Python main.py. And of course, we're getting some problems. I believe that is because of our, yeah. So we actually do need these double dots. I think there's something weird going on with the VS Code terminal, but we do need those double dots because our data is a directory up. So now we can see this is running, and I wanted it as a separate window so that I could just have my TouchDesigner be full screen and then have this little heads-up display here. Although I guess it'll drop behind touch. I have my OSC in 99999. Yeah, I guess maybe there's not a better way to do this. Whatever, it's fine. I'll just make this really tight over here. And okay. Okay, whatever. That should be fine. So now we can just see this running over here while we work with everything here. So now I will clean up our file a little bit. I'll call this Geo All Stations. Just collapse these, call this render. And then actually collapse all of this and call it global rideshare viz. Let's get our parent parameters, start customizing our component. I'm first going to start with a pulse. And we will drop that pulse on our OSC reset channels and values. And now we want to start visualizing these real-time channels. So first we need to get them from 3 channels per event to 1 sample per event with 3 channels. So to do that, we will use a shuffle, or a couple shuffles, really. First, we will sequence n channels. We'll sequence 3 channels. We will then use another shuffle to turn our sequence channels into channels, so basically just like transposing. So now we have our X, Y, and then our gain loss. So I can use a rename and rename it to XY gain loss. And then drop a null, and we can real-time data. Now, I'm going to copy and paste all of this. And instead of having a file in this dat2, I'm going to insert an in, call it in real time, get rid of this. We'll update the name to geo real time. And we can wire in our operator here. Now we can customize this render component a little bit. We can, for example, have background point color, background point alpha, or maybe keep the constant scale at 1. We can always parameterize that later if we want to. We'll want to turn on blending for our transparency and soften the circle up a little bit and drop that down as our color map. And we'll do the same for this as well. Now I'm going to turn off this geo, and that way we should start to be able to visualize some of these stations in real time. So we have about 3,000 samples. Some of these are going to be overlaps, though. So as we are parameterizing this, perhaps we want our active point color to be something different. So we can say active color. We'll have the active alpha, and then we can have active constant point scale as well. And so going up, let's try and change some colors. Very good. We can see this is looking decent. We do want to put on blending transparency. And if we change our alpha to something much lower, we can start to see this look a little bit more like a heat map, where stations that have multiple events are happening, have several layers so that they are brighter. We will fix this kind of tweaking, pulsing thing in a second. But now we are starting to see this real-time visualization. So I just reset everything, and now we see that after one call, we do get some points. They're just very faint, probably pretty difficult to see. Make it bigger. And so we're adding points after each of our calls. And as you can see here, we are still getting just new channels for every additional ride. Okay, so now we need to get rid of this flashing. So I think what's happening here is that as we're adding new channels and shuffling them, it's very, very quick, but because we have 3 channels per event, we need to count in groups of 3. And I think that our shuffle chain is not quite counting in groups of 3 fast enough. So we're getting this kind of twitching when there's a couple channels that get created that aren't lined up. So I think that to get around this, what we can do is convert our OSC to chop, then use a select to select columns by index, start at like column 2. Then go back to adapt, do channel per column. So now we're looking just like this OSC again, and just wire that into our shuffle. And now we're ensuring that we're basically just grabbing the even multiples channels. See here we're starting with XY, and here we're starting with 1. But as long as our X and Y here are still clearly correct, and it's pretty obvious which one is our gain loss, things are working well. So this is a handy workaround, and we can actually use this to do something else, which is use some sort of smoothing to be able to smooth our new stations. So there's 2 things that I wanted to accomplish with this. One is I don't necessarily need to have thousands and thousands of points. It will become somewhat unhelpful if you just have like a densely packed blob of different points. So what I'd rather have is new points adding and old points fading, similar to the event chop almost, in such a way that will smooth our visual a little bit more. So one thing that we could do, for example, is just use this select to grab a window based on our columns, and then just add those columns. So the reason that I grabbed the ones closest to the end is because our OSC, as new channels get added, is just appending them to the end. So by grabbing the most recent columns, I just picked 100 here, but we can customize our component and call this active point max. Make that an integer, I don't know, something like 2000 max maybe, and I'll default to 250. And then we can just replace this 100 with parent.activePointMax.eval times 100. So now we have a dynamic window that's going to be looking at the most recent 250 points worth of data in our OSC and plotting those points. Now, right now, all of these points are being added automatically. And instantaneously, so we're just seeing like new points, and the old points are eliminating themselves concurrently with that, which is not, again, the most interesting thing out there. So what's happening here? So what's happening here seems to be that we have a mismatch because our start column index wasn't updating for some reason. Okay, so I think that's working fine now. Can go back, drop this alpha down a bit. Okay. The missing piece here is the number of new points that we are getting each frame. So what I'm thinking is if I can calculate the number of new points that we're getting with each API call, we can spread out those new points over the 5-second interval before we update again. And that will allow us to kind of sprinkle these new points on and make things look a little bit smoother. So to do that, I'm going to grab an info, and all I want is the number of channels. Then I'll use a chop execute. I'll edit this chop execute, and on value change, what I want to do is calculate the difference, so val minus prev for the difference, and then what I'm going to do is set up a timer that has a fixed length of 5 seconds, and then all I want is the timer fraction. I'll rename that to be IDX, and then I'm going to use an S-curve. I want the steepness to be pretty steep and the bias to be something like this. So this is going to take a lot of our new points will be added at the beginning, and then most of the new points will be added towards the end of the 5-second period with just a little bit of points added towards the end. So just to smooth things a little bit and make it look a bit more organic. So what I want this S-curve to do then is essentially map the timer fraction from the range 0 to 1 to the range 0 to whatever our difference is. So I will set my op scurve1.par.toRange2.val is equal to difference. That's turned on. That's good. We can see now that our toRange is being mapped to 78 because we had here 271 or 210 rather for 71 times 3. So now we have those new S-curves, we have those new points being counted, which is helpful. Now we just need that timer to start. So when the value changes, we can also start the timer. Start.pulse, and this will set the timer starting when we update something, which we can see happening here. Now, we can add the new points. So minus the window, so this is -1, we want to do plus, or actually I will put then a null down and we'll call this null change index. And then we'll add it here. Change IDX channel IDX, and we'll add that to both of these. things are getting a little chaotic. Plus 1 times 3 times 3 minus 1. Okay, so this isn't quite working. And that's fine. Well, I definitely need to be using this input table .num calls instead of this end so that I'm not skewing things by having this aspect here. Oh, we're also not changing by integers, so that's probably part of it. Limit quantize value, and we will floor the value at steps of 1. Ceiling value. Okay. And now, let's see what's happening. All right, so I believe that we should just need to add that offset plus 2 so that we are aligned on all of our data. If you remember at a couple minutes ago when we had the 1 XY here, that was what we needed to have everything formatted right across our shuffle chain. So that's looking pretty good. And now we can see that, while not perfect, we are adding, when we have some changes, we are adding those changes over time. To further kind of even things out, we can add a feedback. A little feedback. And then we can add that feedback to our base image. And then using a level, this is just a super simple feedback loop, by the way. Using a level, you can set the opacity to something like 0.9, or maybe something like 0.99. Well, I guess we can just decay, float, add, something like this, and then we can just do that. 1 minus, boom. So now we have some feedback decay. So our points that drop off, because this is functionally going to be just like a sliding window. So the points that drop off will fade out, and the points that are added will be added over time due to this linearization. So collapse this. Two, and then put my pulse on my feedback. Feedback, and all right, with that, we have a system that is definitely working that will allow us to get our real-time data feed, which is being run via a separate Python process, send the information to TouchDesigner over OSC, and then render that online or in TouchDesigner. So I will finish off customizing my parent component by making a render page. I'll drag the decay over there, and then I will also just parameterize these rendering details. And I will add an out. And with that, we have a nicely visualized real-time rideshare information. I'm not sure why exactly this isn't working. Aha. Oh, it is working. I just had the same colors selected. And then maybe we want to move this point scale. Yeah, okay. So I will drag and drop this point scale. And then I'll do it one more time, just for good order. And so now we can visualize all of our points with whatever alpha we like, and then our active points as well. Looks like I might need some more feedback. Decay. Yeah. Cool. All right, so with anything, there's a lot of playing around that can be done here. This is far from the furthest that you could go, but I think is pretty good as far as getting things tightened up. I do want to go in and actually parent this geo, and then I'm going to rotate 180 degrees, and I will translate over a little bit. And then we can use our ortho. Actually, we can just make it perspective view if we want, and just zoom in here to get it situated how we want. That looks pretty good. Render. Get our resolution on there. We'll render it in 16-bit. And okay, last thing. Last thing is that I will also get my background color. And then we should be pretty set. Okay. And this is looking pretty good. I like it. All right, so that's it. Now you know how to use Python to create a standalone program that will pass information to TouchDesigner over OSC. We're visualizing that OSC information at the moment in the form of instancing to display real-time rideshare starts and stops in New York. A couple extensions, you could think about displaying things and rendering them differently for starts or stops. That would not be too hard. You could also look at using different geographies, obviously different cities. And then something that I would like to do a tutorial on later is going to be using this information in conjunction with Open Map Service and Open Route Service APIs to bring in even more geospatial data to our projects. So with that, I will close this tutorial. I want to thank again all of my supporters. It means a lot to me, and I hope that everyone has been enjoying.